Welcome back, everyone. Today, we're going to be taking a deep dive into something pretty cool. It's kind of where AI meets urban planning.
Yeah.
You know, you might have seen those AI art generators online where you can type in, like, a cat riding a unicorn on the moon and it spits out a crazy image.
hmm
Well, it turns out that same kind of technology can be used to build, like, crazy detailed 3D models of entire cities.
That's right.
So that's what we're going to be exploring today. Right at the heart of all this is something called CityGML.
Okay.
It's kind of like, imagine a universal language, but instead of it being for us, for people to talk to each other, it's like
Right.
a language for computers to understand and work with these like super complex 3D cityscapes.
So these CityGML files, they're actually based on XML.
Oh, okay.
And that's a way to structure data so that it's readable by both humans and machines.
Gotcha.
And what's really fascinating about CityGML is that these models can include like incredible detail,
Oh, really?
So think not just buildings and streets, but like the texture of a building's facade.
Yeah.
know, or even like the species of trees that are lining the street. It's like having a digital twin of a city.
A digital twin, that's wild. So it's not just like a static model, right? It's not like just a snapshot. I was reading that CityGML uses these things called levels of detail.
Yes, or alerts.
LODs, yeah. So it's like you can zoom in and out, and focus on different aspects of the city, right?
Exactly.
Like if you need, I don't know, a high-level view of an entire district, no problem. Or if you want to, like, examine the little tiny architectural details of a single building, CityGML can handle all of that.
It can.
Yeah.
And because it's an open standard, anyone can use it.
Oh, interesting.
That means, for example, architects using one software program
Right.
can easily share their designs with, let's say, city planners who are using a totally different program.
So it makes the whole process more efficient.
Exactly. Much
Okay.
more efficient. Yeah. And it's actually all built on GML3, which is another open standard, but specifically for geographic data.
Gotcha.
So it's kind of cool how CityGML sort of plays nicely with all these, existing mapping tools.
It all ties together. Okay, so we've got this incredibly powerful way to represent cities digitally, but how does AI actually fit into all of this?
Well,
That's what I'm really curious about.
that's the exciting part.
Yeah.
So the research we're looking at today, they describe a system that uses GPT-4o, which is, very advanced AI.
Yeah, I've heard of that one. That's like the big one.
Mm-hmm. It's the big one. And they use that to actually generate CityGML code
Whoa, what?
from natural language descriptions.
So you can like type in, I want a bustling city square with cafes and fountains, and it'll just spit out the code.
Pretty much. You can describe a quiet residential street lined with trees, whatever you can imagine.
And the AI can make it happen in this virtual world.
Exactly. And the way they did this, they used a technique called few-shot prompting.
Oh, okay, what is that?
So basically, they give the AI a few examples of CityGML code, like, just to give it a taste of what it looks like.
Kind of like showing it how to do it first.
Exactly. And then they set it loose, and then it can generate its own code.
Wow, so the AI is like learning the language of city design
Yeah, you could say that.
and then using that to translate our, human descriptions into a form that computers can actually understand and work with.
Precisely.
But how does it actually like define the shapes and the structures within the city? Like, is it just randomly placing things?
That's where geometry comes in.
Geometry, oh boy, flashbacks to high school math class.
Right. But it's actually pretty cool. The AI uses X, Y, and Z coordinates,
Yeah.
just like we learned in school,
Yeah.
to define the precise location and dimensions of, like, every element in the model.
So every building, every park bench, every little detail.
Even the curvature of a road, all of it's mapped out using this coordinate system.
That's mind-blowing. And all of this is happening on IBM's ICA platform, right? So that's showing how these like super advanced AI technologies are actually being used in practical applications today, which is really cool. But I mean, creating the CityGML model, that's just the first step, right?
Yeah.
To actually like bring these virtual cities to life, you got to add the visuals.
Right.
And that's where another type of AI comes in. Diffusion models.
That's right.
Now, I'm a little fuzzy on how those work. Can you kind of break it down for us?
Sure. So imagine you have a pool of water.
Okay.
And you drop a single drop of ink into it.
Okay. I'm visualizing it.
That ink, it slowly diffuses,
Yeah,
right?
yeah.
Spreads out until the entire pool is like a uniform color.
Gotcha.
Diffusion models, they kind of work in reverse.
Oh, interesting.
They start with a really noisy image, like all staticky and messy, and then they gradually remove that noise.
Okay.
Guided by a text prompt, like a description.
So the text is kind of like steering the AI towards the final image.
Exactly, until a clear, photorealistic image emerges.
It's like developing a photograph in a dark room, but instead of chemicals, we're using AI.
Exactly.
And the researchers in this paper, they didn't hold back. They used some of the most powerful AI image generators out there.
Oh, yeah.
DLE, Stable Diffusion, and Adobe Firefly, the whole gang's here.
Specifically, they leveraged Adobe Firefly for this stage in the process.
Okay.
And the results are, well, they're striking.
Yeah.
The AI was able to take the CityGML model, feed it to these different diffusion models, and produce images that are, you could almost mistake them for real photographs.
Well, oh, that good. That's amazing. So you're telling me I can describe a city, and the AI can not only build it virtually, but also create a photorealistic picture of it.
That's the idea. And what's even cooler is there's a few different ways to get from those initial descriptions to those final images.
Oh, really? Like different paths you can take.
Exactly, each with its own advantages and disadvantages.
So it's like choosing your own adventure in the world of AI-powered urban planning.
Yeah, you could say that. But we'll dive into those different paths a little bit later.
Okay, sounds good.
For now, let's take a closer look at one of those paths and see how it actually plays out in practice.
Awesome. I'm ready to see this in action.
It's easy to get, kind of lost in the weeds with all the technical details of how this AI stuff actually works.
Right.
But what's really exciting is, how this can be used to address real-world challenges,
Absolutely.
So one of the paths that the researchers explored, they called it Path of Variant 1.
Path of Variant 1.
Okay, and basically what they did was they fed the AI-generated CityGML model directly to a diffusion model, like DLE or Stable Diffusion, but without any human intervention.
Oh, wow. So it's like letting the AI kind of just run with it.
Exactly. It's like giving the AI the initial description and then just letting it create a city from its own, digital imagination.
That's so cool. So what kind of results did they get with this, hands-off approach?
Well, the AI was, it was remarkably good at capturing the the essence of those descriptions.
Okay.
So, if you ask for, a futuristic city with, these towering skyscrapers.
Right.
That's exactly what you would get.
Wow.
But, it's kind of like asking a talented but maybe, inexperienced artist to paint a cityscape.
Oh, okay.
The overall composition might be there, but it might lack some of the, the nuanced details, the artistic flourishes that, a seasoned architect would bring.
So it's accurate, but maybe a little bit, sterile?
Yeah, I think that's a good way to put it. And that's actually what the researchers found.
Yeah.
They said that this Path of Variant 1 was great for, quickly visualizing a concept, but it, sometimes lacked a certain, I guess you could say, human touch.
Right.
And that's where Path of Variant 2 comes in.
Okay, Variant 2, what's different about this one?
So in this approach, a human expert actually steps in to refine the CityGML model.
Gotcha.
Before it gets passed on to the diffusion model.
So it's like you have the AI assistant that can kind of draft the initial plans.
Right.
And then the skilled architect steps in to kind of fine-tune the design.
Exactly. You're blending the speed and efficiency of AI with the creativity and expertise of a human.
That's a powerful combination. Right. What kind of impact did that have on, the final images that were produced?
Well, the results were pretty impressive.
Yeah.
The human expert could smooth out any rough edges in the AI's design.
Right.
Add details that would, enhance the realism and visual appeal.
Give me an example.
Sure, let's say adjusting the placement of windows.
Oh.
Optimize natural light.
Interesting.
Or, adding subtle variations in the building facades.
Right.
Just to create a more visually interesting cityscape.
It's like taking a good design and elevating it to a work of art.
Exactly. But I imagine this approach also introduces new complexities.
Absolutely.
Well, having a human in the loop brings in, subjective judgments.
Right.
Different architects might have different ideas about what makes a city, beautiful or functional.
That's true.
And the article doesn't really delve into this too deeply.
Yeah.
But it's definitely something to think about,
Of course.
as we kind of consider the wider implications of this technology.
It makes you wonder if you could, train the AI on the works of, I don't know, like specific architects or design styles to create cities with like a very distinct visual identity.
That would be really interesting to see.
Yeah.
How the AI would interpret, different architectural styles.
For sure. Okay, but let's not get ahead of ourselves. We have one more path to explore here. Path B.
Right, Path B.
This one skips the CityGML model entirely. Is that right?
That's right. So in this approach, the researchers just gave the initial description directly to a diffusion model, like del-L, and they just let it generate an image from scratch.
So no CityGML, no intermediate steps, just pure AI imagination.
Exactly. It's like giving the AI a blank canvas and saying, show me what you got.
I love it. What kind of images did this approach produce?
Well, the results were often, they were visually stunning.
Wow.
Full of, imaginative details and unexpected flourishes.
So it's like tapping into the unfiltered creativity of the AI, letting it kind of express itself without, the constraints of a structured model.
Exactly. It was really interesting to see what the AI came up with.
It sounds like this path might be better suited for, artistic exploration rather than practical applications like urban planning.
You could say that Path B excels in creative freedom.
Right.
But it can sometimes, stray from the original description in terms of accuracy and detail.
Gotcha. So it's a trade-off.
It is. It's a trade-off between creative expression and fidelity to that, to the initial concept.
So we have these three distinct paths, each with its own strengths and weaknesses.
Yeah.
It seems like choosing the right approach would really depend on the specific goals of the project.
Absolutely.
But regardless of the path you choose, the fact that we can now generate these crazy detailed and realistic cityscapes using AI is, it's mind-blowing.
It really is.
It just opens up a whole new world of possibilities, doesn't it?
A whole new world.
Yeah. And speaking of possibilities, let's dive into some specific examples of how this technology is actually being used today.
I'd like that.
The article highlights some pretty compelling case studies that really showcase the power of these AI-generated CityGML models in action. So we've talked about how AI can actually build these detailed city models and create these photorealistic images, from just simple descriptions. And we've looked at the different approaches and how they lead to different results. But this isn't just about cool visuals, is it?
No, not at all.
This tech has the potential to really change how we design and analyze, how we even interact with our cities, right?
Absolutely. Think about it. You can now basically create a highly accurate digital replica of an entire city and then use that model to run all sorts of simulations.
Right.
It opens up a ton of possibilities for, urban planning and disaster preparedness.
Yeah.
Even things like optimizing traffic flow.
Or
testing the placement of new infrastructure.
So it's like having this giant digital sandbox where you can just experiment with different scenarios and see the results right away.
Precisely.
That's awesome. You mentioned flood risk analysis earlier.
Yeah.
Can you kind of walk me through how that works?
Sure. So let's say you have a CityGML model of, a coastal city.
Okay.
You can use that model to actually simulate the effects of rising sea levels or storm surges by virtually flooding different areas of the city.
Right.
You can identify, which areas are most vulnerable.
Right.
And then use that information to, to design better flood defenses.
Wow.
Maybe even relocate critical infrastructure.
So it's not just about predicting what might happen.
Right.
It's about actually using those predictions to make better decisions.
Exactly.
And potentially, save lives and property.
That's the goal.
That's incredible. That's incredible. What other practical applications are being explored with this technology?
Well, another interesting one is solar irradiation assessment.
Solar irradiation.
So you can use the CityGML model to analyze how much sunlight different parts of the city receive.
Oh, wow.
Throughout the year. And this can be super valuable for optimizing the placement of solar panels.
Makes sense.
Maximizing energy efficiency.
Right.
Even just designing buildings that make the best use of natural light.
You could even, you could simulate the impact of shadows from, new developments to make sure that existing buildings don't lose access to sunlight, right?
Exactly.
It seems like this tech could be, a real game changer for sustainable urban development.
I think so.
Are there any, real-world projects where this is already being used?
Yeah, actually, the research mentions a project where they used a CityGML model to evaluate different green infrastructure solutions.
Like what?
Things like green roofs, urban forests. To, try to mitigate the urban heat island effect.
Right, right.
And by simulating the impact of those solutions, they were able to figure out the best strategies for creating, a cooler, more comfortable urban environment.
That's fantastic. It really shows how this tech can help us design cities that are not just functional, but, also more livable and sustainable.
Yeah, that's the idea.
That's the dream. But we're just scratching the surface here.
Oh, yeah,
right?
exactly.
What are some of the more futuristic possibilities that, that you're excited about?
Well, one area that I think has huge potential is creating these hyper-realistic virtual worlds.
Oh.
For, training and simulation purposes.
Give me an example.
Sure. Imagine using these AI-generated cityscapes to train self-driving cars in environments that, perfectly mirror real-world conditions.
Right.
Or, creating virtual training simulations for, emergency responders.
Oh, it's a great idea.
Let them practice their skills in a safe and controlled environment.
Yeah.
I mean, the possibilities are really pretty much endless.
It's like stepping into a video game.
Right.
But one that's so realistic in detail that it can actually help us solve real problems.
Exactly. That's the key.
What about creating entirely new cities from scratch?
Oh, that's a good one.
Could AI be used to design urban environments that are optimized for walkability, social interaction, access to nature, all that good stuff?
Well, that's a fascinating question.
Yeah.
The research we've talked about today, it really focuses on recreating existing cities.
Right.
But there's no reason why this technology couldn't be used to design, brand new urban environments from the ground up.
Yeah.
Imagine, feeding the AI a set of parameters like, population density, desired amenities, sustainability goals.
Right.
And then just letting it generate a city that meets those criteria.
We could use AI to explore entirely new urban paradigms.
Yeah.
Move beyond the limitations of traditional city planning.
It's exciting, but also a little bit daunting to think about,
It is. It's a little scary, but mostly exciting, I think.
Yeah.
So much potential there.
This technology, it definitely raises a lot of questions about, the future of our cities and the role that AI will play in shaping them.
Absolutely.
But I think one thing is clear.
What's that?
The ability to generate these incredibly detailed and realistic city models. Using AI, it's a game changer.
It is.
It's a tool that can revolutionize how we design, analyze, and interact with our cities.
Well said. Well said. It's been an awesome deep dive into the world where AI meets urban design.
Yeah.
It has. We've seen how this technology can be used to create stunning visuals, solve complex problems, and even imagine, totally new ways of living in our cities.
Absolutely.
So for all of you listening out there, I highly encourage you to check out the source material.
It's definitely worth a read.
We'll have a link to that in the show notes.
Yeah, check it out.
Thanks for joining us on this deep dive, and until next time, keep exploring.